Okay, now these are the general characteristics of all homologous series. Now I told you that there are the 5 different homologous series that we will be studying, but all of those 5 different homologous series, their main characteristics are going to be same. Now don't get confused in this part. If there are 5 different homologous series, of course their general characteristics are going to be same, but inside individual homologous series it's going to be different. Let me write that better. Okay, first thing, there are going to be 4 pointers. One, they have the same functional group. Now they have the same functional group. I'm writing it as FG. What does that mean? So for example, by the word they have the same functional group, it does not mean that all of the molecules or all of the alkenes, alcohols and all that are going to have the same functional group. No, it means all molecules or all compounds inside alkenes are going to have the same functional group. All compounds inside alkenes are going to have the same functional group. All compounds inside alcohols are going to have the same functional group, and all compounds inside carboxylic acids are going to have the same functional group. Okay, that is how it is different. That is how individually it is going to be the same. All compounds in alkenes are going to have the same functional group, but the functional group in alkanes and alkenes cannot be the same. Okay, so they have the same functional group. This means that if I'm taking an example for an alkane homologous series, so in the whole alkene homologous series the functional group is going to be the same. In all functional group or in all homologous series of alkenes, the functional group is going to remain the same. That is what that means. Okay, I hope this is clear. Second idea says they have similar chemical properties. They have similar chemical properties. Third idea is uh, each member in the series is going to differ the next by an additional CH2 unit. Okay, let's try to understand point 2 and 3. Point 2 means that within the same homologous series, let's say if I'm talking about alkenes, then alkanes, all of the alkane molecules are going to have the same chemical properties. For example, if I'm talking about CH4, C2H6, C3H8, C4H8, all of these are alkane molecules, and these alkane molecules are going to have the same chemical properties. Yeah, by chemical properties, what is meant is that chemical properties is basically when we talk about reaction, how an particular molecule is going to be reacting with other atoms or other molecules. So the way all of the alkane molecules are going to react with any other atom is going to be the same. The way all of the alkene molecules are going to be reacting with any other atom is going to be the same. This is what is meant by they have the same similar chemical properties. Now, each member in the series is going to differ to the next by an additional CS2 unit. Now, I'll just show you what I did above, and I told you I'll show you there. Now here, let's see this. Let's see the idea of this alkane series. Now, in this alkane series, if you notice, every individual or every member in the series, which is the next one, is differing by an additional CH2 unit. You see, here you have a CH4, but if you go to the next member, it is C2H6, which means in the next member you have an additional CH2. You have got one C added here. The C was 1, here it has become 2. So you have got one more C and 2 more hydrogens. It was 4, it is 6. And then if you go to the next one, again there is an additional CH2 unit. If you go in the next, again there is an additional CH2 unit. And now this actually happens within, whether you can say all of the all of what, all of the homologous series. Even in alkenes it is the same. So let's say here you have C2H4. Okay, we have C2H4. This is C2H4. Okay, now this C2H4, if I look at this molecule which is C3H6, C4H8. Now here, this is C2H4. Now C2H4 here is 2C, 4 hydrogen. If you look at this, again there is an addition of 1 carbon and 2 hydrogen. Again, 1 carbon, 2 hydrogen. You look at next C5H10, so you have 1 carbon, 2 hydrogens. So in all of the homologous series, be it of alkane, alkenes, alcohols, or carboxylic acids, it's going to remain the same. As you go down the series, the next member in the series is going to be differing by an additional CH2 unit. That is what it means. And now look at the last point, and that point says they have, I'm just going to be writing this as well, their physical properties, yeah, physical properties, their physical properties, there is going to be a gradual change as they go down the series. And what does that mean? That means by physical properties, it means the melting and the boiling point. So as you go down the series, so again, I'll just write it quickly: CH4, C2H6, C3H8, C4H10. So as you go down the series, you are noticing that the carbons and the hydrogens are getting added, which means the molecule is getting big. So because the molecule is getting big, the melting and the boiling points are going to be increasing as they go down the series. Okay, so from CH4 till C4H10, there will be a gradual change in the physical properties, meaning there is going to be a rise in in melting and boiling points. And that is your idea about the homologous series.